Hello everyone, how is it going? I hope you all are doing well. Let us do question number 6 of exercise 9.3. Here in figure we have a quadrilateral ABCD in which diagonals are AC and BD. Both the diagonals intersect at point O such that OB is equal to OD. Here we can see the sign is given for equal. If AB is equal to CD, then we have to show three things. Now AB is equal to CD is given. Hint is given from D and from B. Draw perpendiculars to AC. So from D and B will draw perpendiculars on this diagonal AC. So we will draw two perpendiculars. One is DE on AC. Similarly BF. Now you need to remember that whenever we draw perpendiculars, it makes 90-degree angle. So this will be 90-degree. Same way this angle will also be 90-degree. Here also this is 90-degree and this will also be 90-degree. First of all, we'll write ABCD is a quadrilateral in which diagonals AC and BD intersect at O. Therefore, OB is equal to OD. And then we'll write, let us draw DE perpendicular to AC and BF perpendicular to AC. Now, when first we have to prove that triangle DOC and triangle AOB, this both triangle have equal area, that we have to prove. So for proving it, first of all, we'll consider two triangles. Look at the figure. We'll consider triangle DEO and triangle BFO. These two small triangles we'll consider and we'll prove congruency between the two. Let us start. We have OD is equal to OB. It is given, right? Now, we have angle DOE and angle BOF. Which type of angles are this? We have learned in chapter 6 that this will be vertically opposite angles, and we know vertically opposite angles are equal. So DOE will be equal to BOF. Also, we have drawn perpendiculars, which means angle DEO and angle BFO both are 90-degree. So they are equal. So we'll write this. In triangle DEO and triangle BFO, DO is equal to BO given. Angle DOE is equal to angle BOF, vertically opposite angles. Angle DEO is equal to angle BFO, both are 90-degree. According to which criteria these two triangles will be congruent? Let us see. Refer to figure. We have written angle DEO, this angle. We have written angle DOE, this angle. And we have written DO, side. Okay. So this is angle, side. If we refer this triangle BFO, then we have written angle BFO, we have written angle BOF, and we have written OB side. So again it is angle, side. Okay, so we'll write by AAS criteria, triangle DEO is congruent to triangle BFO. Now we know if two triangles are congruent, their corresponding paths are also equal. So we'll write CP, are equal. Therefore, we can say DE is equal to BF. These are sides. Okay, so that two sides will also be equal. Now, we know congruent triangles are equal in area. This we need to remember. Okay, students? So, these are congruent triangles. So, their areas will also be equal. Therefore, area of triangle DEO that will be equal to area of triangle BFO, right? And this will be our equation number 1. Now, in this we have to prove area of DOC is congruent to area of DAOB, right? So what are we doing? First we have proved these two triangles are congruent. Now we will prove these two triangles are congruent, and then we will add this two and this two, then we can prove that DOC and AOB triangles have equal area, right? So now we'll consider other two triangles, which are triangle DEC and triangle BFA. These two triangles, students. Okay, let us try to prove congruency. First thing, it is already given that AB and CD are equal. In the question itself it is given. Okay, now what do we see? This DE and BF are perpendiculars, which makes 90-degree angle. So angle DEC will be equal to angle BFA, each of 90-degree. And just now we have proved that DE and BF are equal. Okay, so from these three things we can prove that these two triangles are congruent. Let us write it first. In triangle DEC and triangle BFA, angle DEC is equal to angle BFA because each of 90-degree. DE is equal to BF. Just now we have proved, so we'll write proved. DC is equal to AB, given. Which criteria is this? Let us find out. We have triangle DEC and triangle BFA. As you can see that these triangles have right angle at E and this is right angle at F. So we can consider that these two triangles are right angle triangles. Okay, now we have learned one theorem, that is RHS congruence theorem, RHS rule, wherein if one angle is right angle, and that criteria is for right angle triangles. So here we have right angle triangles, in that any one side and hypotenuse should be equal, then that two triangles are congruent by RHS rule. Here we have right angles, right? Okay, for triangle DEC we have hypotenuse DC. For triangle BFA we have hypotenuse AB. DC and AB are equal, right? So that is one thing. Also we have proved DE and BF equal. So here we'll use RHS rule. Any one side DE and BF and hypotenuse CD and AB are equal. We'll write by RHS criteria, triangle DEC is congruent to triangle BFA. And this will be equation number 2. Now we'll add equation number 1 and 2. These are congruent triangles, so their areas will be equal. So area of triangle DEC, that will be equal to area of triangle BFA. Okay, now we'll add equation 1 and 2. Adding equations 1 and 2 will get area of triangle DEO plus area of triangle DEC is equal to area of triangle BFO plus area of triangle BFA. If we add area of triangle DEO, this triangle, and area of triangle DEC, then what do we get if we add these two triangles? We'll get area of DOC. Similarly, if we add area of triangle BOF and area of triangle BFA, adding these two will get area of triangle AOB. So we'll write, therefore, area of triangle DOC is equal to area of triangle AOB. This first we have proved. Now in second one we have to prove area of triangle DCB is equal to area of triangle ACB. For proving area of triangle DCB equals to area of triangle ACB. How will we prove, students? Look at the figure. We have already proved that DOC triangle is equal to AOB. This both areas are equal. Now, look at this triangle DOC. When we will get triangle DCB? If we add triangle BOC in this triangle, then we'll get triangle DCB, right? Similarly here, if we add triangle BOC in this triangle, then whole triangle ACB will get. Okay, so easy. So what do we do now? We will add area of triangle BOC on both the sides. We will write number 2. Area of triangle DOC is equal to area of triangle AOB. We have proved. What do we do? Adding area of triangle BOC on both the sides. Then we'll get area of triangle DOC plus area of triangle BOC is equal to area of triangle AOB plus area of triangle BOC. And if we add this two, then we get area of triangle DCB is equal to area of triangle ACB. Okay, how? We have triangle DOC. In this, if we add BOC, then we'll get whole DCB triangle. Same way we have triangle AOB. If we add triangle BOC in it, we'll get whole triangle ACB, right? So we have proved this number 2. Now in number 3, we have to prove DA parallel to BC or ABCD is a parallelogram. DA parallel to BC or ABCD is a parallelogram, which means if these two sides are parallel, then obviously it will be a parallelogram. Okay, for that, what do we do? We have two triangles, triangle DCB and triangle ACB. Both the triangles are having same base, that is CB, and they have equal areas. Just now we have proved that area of DCB is equal to area of ACB, right? Now we have learned theorem 9.3 that two triangles having the same base, here we have same base CB, and having equal areas lie between same parallels, which means if two triangles are on same base and they have equal area, then they will lie between parallels, same parallels, which means AD parallel to CB. Number 3, two triangles having same base and equal areas lie between same parallels. Here we have triangle DCB and triangle ACB on the same base CB and having equal areas. Therefore, according to theorem, they lie between same parallels CB and DA, which means DA parallel to CB. Now, if one pair of opposite sides parallel, then it is a parallelogram. Therefore, DA parallel to CB, or we can say that ABCD is a parallelogram. Here we have completed question number 6.